Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And what I have for you today is a short talk that I gave at the launch of the Today Software magazine. I was invited to give kind of impromptu short talk on the past and future of the IT industry, because this was the theme of the current number of Today's Software magazine. And I had some things to say. I gathered together a few notes, and I'm gonna start from the same notes and kind of give a similar talk on video. So first of all, when I think about the past and present of IT and the future, the thing that first thing that comes into mind is my first computer. And my first computer was an HC90. This was ZX Spectrum clone. And when you started it, it booted directly into BASIC. And you had to know BASIC to interact with the computer, which was really cool, actually. But it took me a few months, and I got over BASIC in the sense that I found the limitations of the language, the limitations of the machine, basically, because the problem was not as much the programming language, but that the machine was very limited. And because of this, I moved into assembler, ZX80 assembler. And this was pretty interesting. The most interesting thing being that what you had to do was to write in assembler all the instructions, but if anything went wrong, the computer would reset and you lose everything, and you have to start from the beginning. So that's how I started programming, first with BASIC and then by writing code in a very punishing, let's say, environment. But it was fun. And this happened in high school and I had time and it was really fun. And it shows us that we've gone really far. So the tools that are today, the tools that we are using today, even the free tools are just amazing. You can do a lot in programming with just Vim plugins. There's a lot that you can do. You have a cloud, we have infrastructure as code, we have automated tests, and recently AI coding assistants, which, okay, we'll see how well they fit with the development process. The second thing I'm thinking when I think about the past of IT and the future is that there are three types of ideas in software development. First of all, there are ideas that are marketing, that are plain fads and fashion. Things that come and go, things that at some point are pushed as very important by various organizations, but they end up just not being used that much. And part of it is the developer culture. Part of it is the lack of maturity in developers. And this is something that we are still struggling with and kind of working through it as an industry. The second type of ideas is ideas that go but come back into a different form. For example, cloud is the new mainframe. It's the same model, only, okay, it's much better in terms of offering, although mainframes were pretty amazing and a lot of transactions still go through mainframes, so we shouldn't discount them as easily as we do. Okay, they are a bit on the old side. You have to learn things that you can only use with mainframes, and that's a big problem, but if they were kind of more open, then who knows what we do with mainframes. But beyond the actual practical aspects of mainframes, cloud is the new mainframe because it's basically the same idea. You rent the infrastructure for someone else and they manage the infrastructure. That was the business model for mainframes. And the services that we have on cloud are, of course, much more sophisticated today, but it's still kind of the same idea coming back in circles. There also microservices is the new object-oriented programming. Fundamentally, a microservice, if you think about it, a microservice should have its own database. It has its own interface. It does, it encapsulates both the data and the behavior in the same thing. And the biggest idea with microservices is messaging. You communicate between microservices with events, with messages, and that's basically what Alan Kay said about objects, about object-oriented programming, that the biggest idea in OP is messaging. And Alan Kay also said at some point that every object should have an IP, which is basically what we are doing with microservices. So objects and microservices are extremely close related. It's the same idea coming back in a new form with its own trade-offs. The third idea is, the third type of ideas in software development are ideas that are stable, ideas that stand the test of time, ideas that when you revisit them, they are still as powerful, as useful as they were 10, 20 years ago when they were written, when they were publicized. The difference is, and what varies and what kind of puts off developers a lot of times, is that each of these ideas that is stable has its own applicability domain. No practice is general. So each practice has its own applicability domain. What changes about these practices is often how you apply them and where you apply them, not as much whether they are very valuable or not. So we have ideas like test-driven development, clean code, refactoring, domain-driven design, design patterns, continuous integrations. These are ideas that are valuable and that will still be valuable for a very long time. And it takes some time to master these practices. It takes some time to understand them deeply. And it takes some time to understand where they apply, what is their domain of applicability, where it makes sense to use them, where it doesn't make sense to use them. But you will need some kind of rules for writing code that is easy to change, and this is given by clean code and solid principles, for example. You will need some kind of process for writing that code, and this is test-driven development. So there are a lot of things that are stable here, and unless something fundamental changes, these ideas will stay practical, will stay useful, will be stable. And this brings us to the big unknown. The big unknown is how far can AI go to help us with programming? Well, I've done a whole video about this last Saturday, so I think I've discussed in detail in that video. But the fundamental thing here is what seems to have happened is that the AI, the LLM revolution, to be very clear, the large language model revolution, or the Gen AI revolution, has passed. What we had in the past years has been incremental improvements. Slightly better models, better integration, more languages, because, okay, in natural language and English is a language, but it's also video is a language, audio is a language, code is a language, and so on. But all AI does, all Gen AI does, is right now to go incrementally. And they attempt to solve some of the issues with imprecision and all that, but fundamentally those are very difficult to solve. So unless they will be there, unless it's true that they will end up getting to AGI, we will have kind of same programming models, but with some AI assistance. And it's not yet clear where the AI assistants will be, how they will help, and so on. There are some trends, there are some things that are kind of starting, but it's not yet clear. We don't know. And I don't want to go into a lot of speculation about this. But I will assume that we won't get AGI. I am not confident that we'll get to AGI. I'm not confident that the people who are claiming that AGI is very close in time actually know or are certain of this. There's so much money involved. There's so much hype. There are a lot of things, a lot of benefits for people to kind of keep the hype up for AI right now, because more investments are coming and it brings more money and so on. So right now, I'm not convinced. And the problem of AGI is fundamentally different than the problem of Gen AI. And one of the things is that we have no idea what AGI will, well, we have no idea how the brain works or how conscience works and all these things. We can't even define conscience very well. So consciousness, so it's very difficult to reason about these things. And apparently nobody knows, not even the people who are specialists in these things. So because of this, I will ignore the AGI. If AGI comes up in the future, then everything changes. But I don't believe it will in the next 10 years. If I were to bet, it would be probably 70% against AGI coming up in the next 10 years. So with this being said, let's discuss about a few challenges. And this is a bunch of challenges. They are not ordered, they are not organized, but these are the first that came to my mind when I was thinking about the future of software development. First problem that I see is the fact that we still have bugs that are predictable, that are easy to prevent, and You may know by now my favorite example, leap years. We had 29 February 2024, a bunch of systems went down around the world, and we know that on 31st December 2024, we'll have more systems going down, those that assume that a year is 365 days long. We know that. And honestly, this is not acceptable. This is something that the industry should get over. It's not something that a professional organization, a professional body, a group of professionals is doing. Then the next thing is that we still haven't really come to a good understanding or to grasp the fact that programming is knowledge work. It's very difficult to get that. And this is true for managers, it's true for the business side, but it's true for programmers as well. So programming as knowledge work means that you need more brains to solve a specific problem, which means collaborative problem solving. It means that you work incrementally, that you get feedback, that you make prototypes that you throw away because you are exploring alternatives. It means a lot more things than it would mean to just focus on production, just focus on pushing things and making them work with the first idea that comes to your mind. So we still haven't gotten to grasp with it. The second thing that we are not yet let's say we haven't dealt with, not really, is that programming is a humanistic activity as well. It is technical, definitely. Of course, you need to know the technical aspects. But in the end, what you do most of the time is to write names and to use names given by other people. And you write names because you want other people to understand what you write. And you write the code so that it does something for some people, for your users. So we write the code for people, we write products for people. Programming is fundamentally humanistic, as well as technical. So we still haven't gotten very good, with this idea. Many programmers would protest that it's not true, but it's true. The next thing we should have to deal with is that you have a lot of immaturity and we keep reinventing the wheel. We keep reinventing the wheel. And my favorite story is when Ruby on Rails came up, and in the first years it was an effervescence of people very happy with Rails, but when people were trying to tell them, look, there's a design pattern here that you should use, they would say, oh, design patterns, those are for Java, for the old technology. We are the new kids, and it's so great. And of course, after that, their programs grew, and they realized that maybe they need some design patterns. So we are too quick to dismiss old solutions, established solutions, practices that work, even if they are weird, like test-driven development. We are too in a hurry to reinvent things that already work. And that's a big problem in the industry, because as long as we are spinning our wheels in empty space, it doesn't help. We don't get forward. We're just in the same place, trying different variations of the same ideas. And the final one that I like to talk about is security. We have a big problem with security, and there are a number of problems. But the one that I will choose to focus on is the fact that we have two camps that take care of security. We have security experts and we have programmers. And these camps don't speak the same language. One of my favorite things in security is that when people use the word exfiltrate, people exfiltrated, hackers exfiltrated data from an attacked application. What this means is they copied the data out, right? But it sounds better. It's their language and good for them. Okay, so they have a specific language. That is not a problem. The problem is programmers. If a programmer tries to read some of the security reports, some of the security papers, they are filled of this vocabulary and it's very hard to understand. So even if you want to, you cannot quite get close to it, at least not easily. And if you don't want to, then of course it's a problem because you have blind spots when you're writing code. Also, the two camps have different approaches, which is fair enough. Security specialists will focus on the most paranoid things, while developers, they want to build stuff, right? So what we did at Mozaic Works, we created a learning program called Secure Coding, which is about programmers, as one participant told me, getting paranoia plus. So it's about increasing a little bit the level of paranoia of developers. We don't want to get them to the level of paranoia of security specialists. That's not the point. But at least whenever they write or change a line of code, keep in mind and go back to it and look at it from the lens of security. And think, what could somebody do with this line of code? Is it correct? Can somebody exploit that in any way? And I think this is a very powerful thing. It's something that we will need to do. Of course, a lot of security is in infrastructure, and that's great. But we need really to have this security mindset with developers as well. So this being said, what I see is that in the past, there are good things about the future. Let's say there are good things about the future because there's a lot of progress in tools, and maybe we'll get some smart assistants and so on. But there are also some fundamental problems that we need to work on as an industry and kind of explain better to ourselves and to others what we are doing, why are we doing it this way, how it helps, and to focus on the things that matter rather than on the things that are passing by. This is it. Thank you kindly for the view. If you have any comments, please leave them below. I'd like to hear from you. Until next time, remember to think, design, and work smart. See you next Saturday.